Hello, welcome back to our classroom. Today we talk about matrices, and in this video we're going to be talking about the basics of matrices and addition and subtraction of matrices. Our objectives for today are: one, to describe a matrix, to list the basic types of matrices, to add and subtract matrices, and to do some scalar multiplication. We're also going to do a little bit of problem solving as it relates to matrices and equations. First up, let's talk about what a matrix is. A matrix is a set of numbers or symbols arranged in rows and columns so that they form a rectangular array. The numbers or the symbols are called the elements of the matrix. Now, from time to time, you may go about, and in a cambio or in a bank, you may see a foreign currency trading chart such as this, where numbers are arranged: buying rate, selling rate, and the name of the currency, in rows. These are rows, and columns. And these are the columns. And there are several other charts that are arranged that way. Sometimes in your textbooks, when the figures are displayed in a table, such as import, export figures of particular crops over years, or oil exploration, export, import, or production, you may see different charts that display different numbers in rows and columns. As long as numbers are displayed in rows and columns, it can be treated as a matrix. Also, in restaurants, there are meals, and beside the meals, there are the prices beside them. So any kind of information that is arranged in rows and columns, we can treat those as matrices, and simply by putting a bracket around it. So a matrix has rows. Row. This matrix has 1, 2, 3 rows, and 1, 2 columns. And each element of the matrix, each symbol or entry into the matrix is called an element. Now, matrices are normally named using capital letters. And here we have some matrices, A, B, and W, named with capital letters. This matrix has 2 rows. It also has 2 columns, and because of that, we call it a 2 by 2 matrix. This matrix has 1, 2, 3 rows and 2 columns. So 3 rows, 2 columns, we call it a 3 by 2, and not a 3 times 2, but 3 by 2. And this one has 1 row, but 1, 2, 3, 4 columns. So we talk about the dimensions of a matrix, and the dimensions of a matrix simply refer to how many rows does it have, how many columns does it have. Those are important as we get into matrix computations, where we talk about addition and subtraction, multiplication. Those are very important that we understand the dimensions of a matrix, because those have implications for how we can add, subtract, or multiply. So rows, columns. And this particular matrix, as this one, its dimensions are 3, 2. So we say this is a 3 by 2 matrix, just as this one is. Now let's talk about some types. These are not all the types. There are others, but for our conversation and discussion here for CXC purposes, these are the types we'll be focusing on. So we have a row matrix. It's called a row matrix simply because it has only 1 row. And this is a column matrix. There could be more numbers in the column, but the idea is it has only 1 column. And because it has only 1 column, it's called a column matrix. This matrix S is a square matrix. It's a square matrix because it has 2 rows and 2 columns. So the number of rows and columns are equal. There may be more rows and more columns. You can make them bigger, 3 by 3, 4 by 4, 5 by 5, as the case may be. But as long as the number of rows is equal to the number of columns, it's called a square matrix. A null matrix has only zeros. It doesn't have to be square. As long as all the elements in it are 0, it's called a null matrix. Now, a diagonal matrix needs to be square. because the idea of a diagonal is that it's drawn from one end to another of, for example, a rectangle or a square. And so this here, this line, represents the diagonal, and the diagonal has non-zero numbers while the other diagonal has zeros. So this is called a diagonal matrix for that reason. And the last one here is called an identity matrix or a unit matrix. This identity matrix is similar to the diagonal matrix, except that it only has ones on the main diagonal and zeros everywhere else. Like I said, there are other types of matrices, such as triangular matrices, upper triangular, lower triangular, etc. But those are not for this discussion, so we're not going to go into them. Now, how do we add or subtract two matrices? As a rule, matrices can only be added or subtracted if they have the same size or dimensions. So this is important to remember. Remember to jot it down somewhere and memorize it. You can only add two matrices if they have exactly the same size or the same dimensions. So here we're going to try out some additions using M, P, and R. If we try to add M and P, when we add matrices, by the way, we add by their positions. I'll demonstrate that in a moment. We add the positions. So let's add M and P. M is 5, 0, negative 2, 4. So we put our 5, 0, negative 2, and 4. And we're going to add that to the matrix P, which is 5, 2, 1, 0, 7, and 4. Now what happens here when we try to add this matrix together, let's look at the positions. So this number corresponds to this number, the first one in this one. This number corresponds to the second one. I should use a different color for that. So this one corresponds to this one. And this number here corresponds to this number. And this 4 would correspond to that 7. Now you can see here that these matrices do not match. And because they do not match, we cannot add them together. So here, right here, we have what we call a mismatch. And if you try to add this on a calculator that can add matrices, what it will tell you is a dimension error, simply because there is no row, there's no column in this matrix M that is similar to this one in this matrix P that you can add them together. But let's add together two matrices that can actually be added so we can demonstrate better what can be done and how it should be done. So here we are adding M and R. So let's write on M, 5, 0, negative 2, and 4. And we're going to add it to R, which is 3, 2, 6, 1. Now, like I said, we add positions. So the 5 and the 3 are in the same position. So we add those, 5 plus 3. The 0 and the 2 are in similar positions. So we add those together. We say 0 plus 2. Likewise, the negative 2 and the 6 are in similar positions. So it's negative 2 plus 6. And the 4 and 1 are in similar positions. So we add the 4 plus 1. Once you have arranged them like that, positions, first to first, second to second, first to first, second to second, you can get more complicated than that and say first row, first column, to first row, first column, first row, second column, to first row, second column. But just generally looking at it, you can understand that this one and this one are in the same positions. This one and this one are in the same positions. This and this and this and that. And you add them as you see them there and you get your result. So our result is going to be 5 plus 3 gives us 8. 0 plus 2 gives us 2. And 6 plus negative 2 gives us 4. And 4 plus 1 here gives us 5. So this is the answer that we get when we add these two matrices together. Remember, in this one, they cannot be added because there's a mismatch. This one has 2 rows and 2 columns. This one has 2 rows and 3 columns. And because of that, we cannot add them together. But these two are exactly the same size. And because they're exactly the same size, we can add them together by adding their positions. Let's continue. The same thing can be done for subtraction. Oh, by the way, I didn't put the plus, so let's put the plus. All right. So the same thing can be done for subtraction, where you say 5 take away 3. Let's do that down here. So we say m take away r, and we can write it down as m, which is 5, 0, negative 2, 4, and we're going to subtract the r. I should push this over some more. M take away r. So we have 5, 0, negative 2, 4, and minus 3, 2, 6, 1. And again, because they're in similar positions, we can go ahead and write it down. So 5 take away 3, 0 take away 2, negative 2 take away 6, and 4 take away 1. And that gives us now 5 take away 3 is 2, 0 take away 2 is negative 2, negative 2 minus 6 gives us a negative 8, and 4 take away 1 gives us 3. And this would be the result of our subtraction of m take away r. We can do that because they are the same size. So again, we can only add or subtract matrices that have the same size. If they do not have the same size, we cannot get a result. All right, let's continue. We can also multiply a matrix by a number. This number is called a scalar. We can multiply a matrix by a matrix as well, but that's for another lesson. In this lesson, we're just concentrating on multiplication and on addition and subtraction. And here we are mixing in some scalar multiplication. A scalar is simply a number. So we're going to multiply this matrix M by 3. So let's say 3m would be 3 times the matrix M, and M is 5, 0, negative 2, 4. We multiply that by 3, then 3 times 5. Just as though you were using the distributive law, the 3 will be distributed across each element in the matrix. So it's 3 times 5, just writing it out. You don't have to write that out. But 3 times 0, and 3 times negative 2, and 3 times 4. So that gives you, when you multiply it out, 3 5s are 15, 3 0 0, 3 times negative 2 is negative 6, and 3 times 4 gives us 12. So this is the result of multiplying 3 by m. It's pretty straightforward, just as though you were removing a bracket. You use that number outside your bracket to multiply everything inside. The same rules apply here with the distributive law. Here we can find 3r minus 2m. So let's say 3r, which is 3, times r, which is 6. Well, I'm writing out the answer there. Let's fix that. 3 times 3, 2, 6, 1. And we're going to subtract 2 times m. And m, as we know, is 5, 0, negative 2, and 4. Now we can multiply that. 3 times 3 gives us 9. 3 2s are 6. 3 6s are 18. And 3 1s are 3. Put that in your bracket. Brackets are important when it comes to matrices. So we're going to subtract now. 10. 2 5s are 10. 2 0s 0. 2 times negative 2 gives us negative 4. And 2 times 4 gives us 8. So we're subtracting all of this. And here we have now that 9 take away 10. Remember, the positions are important. 9 take away 10. And we have 6 take away 0. we have 18 take away negative 4, and we have 3 take away 8. And this leaves us with 9 take away 10 is negative 1. This is 6. This is 22. And this is negative 5. So this will be the result of our multiplying out 3r minus 2m and doing that operation. Also, we could find, using a different number, for example, we could say, let's find half of p. And that would be equal to half times 5, 2, 1, 0, 7, 4. And half of 5 we know is 2.5. Half of 2 is 1. Half of 1 is 0.5. Half of 0 is 0. Half of 7 is 3.5. You could also write these in common fractions. And half of 4 is 2. So you can multiply any matrix by any number, and simply by using that coefficient, that number, to multiply all the elements inside the matrix to get your result. Now we're going to look at a question that uses the scalar multiplication and mixes in a couple of unknowns to solve an equation. So we are told that given A is x3, 5, 1, and B is negative 2, 7, y 0, R is 10, negative 5, 13, and 3. We are supposed to use that information along with that 3a minus 2b is equal to r to calculate the values of x and y. So let's do that. So 3 times a minus 2 times b is equal to r. So let's set that up. 3 times a is x3, 5, 1, minus 2 times b is negative 2, 7, y 0, and that is supposed to give us r, which is 10, negative 5, 13, and 3. Now let's multiply this out. This will give us 3x, and 3 times 3 here gives us a 9, 3 times 5 gives us 15, and 3 times 1 gives us 3, minus, let's multiply this one, 2 times 2 gives us, 2 times negative 2 rather, negative 4, and 3 times 7 here gives us 21, not 3. I said 3 times, it's 2 times. 2 times 7 here gives us 14, and 2 times y gives us a 2y here, and 2 times 0 is 0, and that is supposed to give us 10 minus negative minus 5, 13, and 3. All right, we've set it up. So let's look at it now. 9 take away negative 4, 9 take away 14. Let's look at the positions and see what happens. 3x minus 4 should give us 10. Those are in the same positions. So we can write that down as 3x minus negative 4. 3x minus negative 4 gives us, in this position, 10. For this position, we have that 9 take away 14 is equal to negative 5. That is true. We have in this position 15 take away 2y. 15 take away 2y is equal to 13. And in this position, we have 3 minus 0 equals 3. We do not need to write out these two, but I wrote them down so that we can see that the calculation is actually correct. This and this. We didn't need to write these down, but 9 take away 14 is indeed -5, and 3 take away 0 is indeed 3. So we can trust this one, and we can also trust this one. By doing that, we can write down these two equations. 3x minus -4 is equal to 10. Which tells us that 3x plus 4 is equal to 10, and we can solve that easily by saying 3x is equal to 10. Take away 4, which means 3x is 6, and by that we know that x is 6 over 3, which is 2. From this one, 15 minus 2y gives us 13. We can now look at it and say, okay, 15 minus 13 is equal to 2y, and 15 take away 13 is 2 equal to y, and that tells us here that y is equal to 2 divided by 2, which is 1. So our solutions are x is equal to 2 and y is equal to 1. So in our addition and subtraction of matrices, we can also toss in letters to make it more interesting by creating equations and solving simple equations like these. So what have we done today? We have looked at what matrices are. They are sets of numbers arranged in rows and columns to form rectangular arrays. We understand that matrices have dimensions, they have rows, they have columns, and they are named by the rows and columns. There are particular types of matrices that we're going to come across. Row, column, square, null, diagonal, identity. We have looked at how to add two matrices. Matrices can be added or subtracted if they have the same size. So we cannot add these two because they don't have the same size, but we can add these two because they're exactly the same size. And you add matrices by adding the corresponding positions in each matrix. And we can look at how we can multiply a matrix by a scalar by simply multiplying that matrix by the number outside as if we're using the distributive law. And final thing, we look at how we can solve an equation using matrices by simply using the fact that we can add and subtract the positions and using scalar multiplication. Thank you for watching. Remember to subscribe. And in other videos, we'll be looking at how to multiply matrices, how to look at determinants, inverses, simultaneous equations. So look out for those coming up. Subscribe so that when those videos come out that you can be notified about them and continue your learning. Thanks for watching.